All right, let's start off with questions from homework. I have questions already because I've noticed this trend already. It is, nope, these four, right? A lot of us struggle with it. We struggle with it because we overthought it. We are overthinking things. Because let's look at 61. If for 61 I just did this, let me erase part of the problem. Could we do that? Can we find the cosine of pi over 3?
Yes.
In fact, can someone give me the cosine of pi over 3? Magic?
1/2.
It'll be 1/2. All right, so that one equals 1/2. Well, now what if I got rid of that and it's just the sine of pi over 3? We can do that as well. In fact, since we know the cosine, we know this is going to be square root of 3 over 2. That's all it's asking you to do. It's asking you, can you find the cosine of pi over 3? Can you find this? Plug it into this fraction, and then we're going to go ahead and simplify. Most of your points are right here, but I don't want a fraction divided by a fraction. It's ugly. It's impossible to work with. So what we're going to do, if I ever have a fraction being divided by another fraction, I'm going to do, I don't know if you remember this, is keep, change, flip. I'm going to keep the top one. I'm going to change this to multiplication, and I'm going to flip the bottom one. All right, so that's keep, change, flip. So we're going to keep the top fraction, change the sign to multiplication, and then we have 2 over square root of 3. Well, our 2 over 2 is going to cancel out, and I'm going to be left with 1 over square root of 3. That's an ugly looking fraction because we don't want radicals in the denominator. Do you remember that from, I think you did that in Algebra 2. So I'm just going to multiply the top and bottom by square root of 3. Multiply the bottom, multiply the top, and we're going to be left with square root of 3 over 3. And that should have been the answer. Is that clear? It's just a little overthinking, right? You're just like, I can't find this whole thing on the unit circle, so break it into small chunks. All right, the other hard one was probably this one, because there's no pi over 3 plus pi over 6 on our unit circle, as written. You are allowed to use any math you want to simplify anything in parentheses. All right, so if this said 2 times this or something, you would just add these together, and then you do what's on the outside. So forget about the sign for a minute. If you forget about the sign for just 1 minute, you just focus on what's in the parentheses. All it's asking you to do is to add pi over 3 plus pi over 6. So that's the first thing you're going to do. You're just going to pull that out and go pi over 3 plus pi over 6. Have to have a common denominator. I'm going to use 6, so I'll have 2 pi over 6 plus pi over 6. That equals 3 pi over 6, which is just pi over 2. So sine of pi over 3 plus pi over 6 is just sine of pi over 2. Pi over 2 is 90 degrees, so it's the straight up one, so it's just that 0.01, so my sign is going to be a positive 1. Yes, Liam?
This is pretty basic, but when it's cosine or sine cosine, when you're looking at on the unit circle.
Let me look on the unit circle really quick with you.
Yeah.
All right, I'm looking at the unit circle.
Yeah. So the numbers, like in the parentheses, it goes cosine sine.
Always.
Okay, cool.
Always cosine sine.
All right.
Always. For whatever reason, I had students that say, oh, it's alphabetical order, that's how I remember it. I just remember it just being cosine sine. It's not rocket scientry. But however you want to remember that, alphabetical, whatever. But yes, that's 100% correct. All right, does that clarify these two? So if you didn't do those 4, make sure you get these 2 done, because these will be good practice then. Other questions from the homework? Yeah?
Can you do number 55?
Sure. You said 55?
Yeah.
Okay. So I have negative 17 pi over 6. Bleh. Do I want to use a negative 17 pi over 6? No. So I'm going to add 2 pi to it until it's positive. 1/2 pi is not going to cut it because 17 divided by 6 is bigger than 2, so I'm actually going to add 4 pi to it. I'm going to go ahead and shortcut this. Please tell me if I make a mistake sometimes when I shortcut stuff. So I'm actually adding 4 pi, but I'm going to write it as the fraction right off the bat. So I'll have 24 pi over 6, but just remember this is actually just 4 pi. I just rewrote it. Alright, so that is going to give me 8 pi over 6, which can simplify down to 4 pi over 3. I'm more than happy to continue going. Is this far enough, or do you want me to keep going? Okay. Let me just, I'm not going to complete the whole problem. I'm going to let you complete it if you were stuck on it. But just remember that 4 pi over 3 is right here. Yeah, did I make a mistake?
Isn't it 8 pi over 6?
Did I?
7 pi over 6? I'm sorry.
Was it 7 pi over 6? Oh, yeah, yep. Yep. That was my mistake. Thank you. For anyone that was just like, what is he doing? So it's 7 pi over 6. So that means we just go to our unit circle. We find 7 pi over 6. So I'm looking for this angle here. So it's going to be 7 pi minus 6 minus pi to get you that reference angle. Liam?
So for the test, there's gonna be like a blank unit circle. And
Yep.
We can use that to like for this.
Mm-hmm. Yep. And my advice to you, if you don't like using reference angles, if I don't ask specifically for a reference angle, you don't have to use them. I personally use reference angles because if I'm way out here, I just know where things are. I know what I have to do. Like if I see 7 pi over 6, I'm thinking I have to get back to pi. That means I need to subtract 1 pi over 6. So I just have to look at pi over 6, and I know my answer from there. Okay? But if you don't like using reference angles, I'm not going to force anyone to do it. All right? Because this is all brand new stuff. Sometimes it's just like, I just want to get down. If I'm here, I want to say my sine and cosine. Like I'm still stuck on doing that, let alone converting stuff. All right? But is that far enough for your question? Thank you for catching that math mistake. But you said that was good?
Yeah.
For we got, okay. Other questions? Yeah, if you're ever struggling to use negatives, just make it a positive. Makes your life easier. You don't necessarily, you could have done the negative all the way around, but too much work. Other questions? Going once? Going twice? All right, sold to the highest bidder. We are going to use our calculator today. Yay, so take out your calculators if you got them. If not, pay attention and take notes on how to do it. It's not complicated. We're just scratching the surface of what your calculator can do. So probably not.
Okay.
Because it's got to be your graphing calculator.
Oh, right. Okay.
Just I'll have a graphing calculator up here.
Okay.
So just pay attention along with me. Because it really is only one button you have to know how to use.
Okay.
All right. So my warning sign is make sure you are in the proper mode. Your calculator has a degree mode and it has a radian mode. If the problem has radians in it, you better be in radian mode. If it's got degrees in it, you better be in degree mode. The number one missed thing on a test, if I let you use your calculator on portions, is people are in the wrong mode. That's the number one mistake. So every problem that I say use a calculator, solve it, make sure you're in the right mode for every single problem. So our first one says find the sine of 4.27. How do I know that's in radians? Yes?
No degrees.
No degree symbol. If there's no degree symbol, automatically it's radians, whether it has pi or not. So that means we're going to go to our calculator. We're going to go to our calculator. Let's see if I can get to my calculator. Get out of this guy. Get out of here. There is my super magic calculator right there. Looks just like any TI. If you do not have a TI calculator, we can figure, like if you have a Casio, I think, is that a Casio?
Yeah.
Yeah, I'm not 100% sure how to do it on Casio right now. I forgot. There's a different way to get radians and degrees. You can just look up online, and if you can't get it, just tell me, and I'll figure it out for you. In fact, after this class, I'm going to look it up, so you can email me and say, did you figure it out? I'll let you know. All right. So the only key thing is you need to switch to radian mode. You have a mode button. You have a mode button right here. All you're going to do is you're going to click that mode button. Well, first you got to turn it on, apparently. Weird, huh? And I'm going to click that mode button, and you're going to see this two little thing that says radians and degrees. Currently, my calculator is in degree mode. So you're just going to hit your down button until you get to radians. You're going to hit enter. So I just click down, hit enter, and now I'm in radian mode. Now I'm just going to hit second quit. And now I'm all set. Now all you're going to use is your sign button. You got a dedicated sign button right there. We're going to hit sign of 4.27. Now you could hit enter right now and it's going to calculate it. You don't always, if you don't close it off, your calculator's going to do whatever's in here. If you have some kind of math in here, so if I have 4.27 plus something, then you want to close it off. So I always just stick in the habit of closing it off no matter what. So I'm going to hit this close parenthesis button, and I'm going to hit enter, and that's your answer. I believe it says round to the nearest 4 decimal places. Your answer would be negative 0.9037. So I'm going to go ahead and write that in there. This is about negative 0.9037. So those of you that don't have a calculator, if I Casio, we just got to figure out how to get to the degree and radian. That's the only key part that we have to do. All right, let's go back. Now we need to be in degree mode because that's the next problem. So we're going to hit that mode button again. We're going to scroll down to radian, and now we're going to hit right. So as soon as you get there, hit the right button, and then hit enter. Now that is selected. Now we're in degree mode. Once again, second quit. And I forgot what we had to do. We have to do cosine of, and real quick, just a little information about your calculator. This is subtraction. This is your negative sign. So if you ever get an error while using a subtraction sign, it might even come up with saying like you used the wrong sign or something. Just know this is subtraction. So I'm going to hit this button down here. So that is my negative button, not my subtraction button, my negative button. And we have negative 39.46. Close parenthesis. And that's going to come out to 0.7721. Right, because that 0 is going to bump up to 1 because of the 6. All right, so let's go ahead and write that down. So this is going to be about 0.7721. Jack, did you figure out where the degree and radian is?
No.
No, okay. It's in one mode, so you get one of these right. It'll already be in one of those modes, so if you type in sine of 4.27 and it comes up right, you're in radian mode. If it comes up wrong, you're in degree mode right now. So even if we can't figure out, at least you get 50-50 shot on each problem. But we'll figure it out. All right, questions on using your calculator. Minus, I don't know where my degree radian thing is. Okay. Then we're going to move on to the fundamental identity of trigonometry. The fundamental theorem of trigonometry is based solely on the Pythagorean theorem. And the Pythagorean theorem is, if I have a right triangle, side squared plus side squared equals, do we like the Pythagorean theorem?
My favorite theorem.
Oh, yay. So it's side squared plus side squared equals our hypotenuse squared. But what does that have to do with trig? Well, remember, with our unit circle, we can create a whole bunch of right triangles. That's how we figured out that x and y stood for cosine and sine. So let's apply the Pythagorean theorem to our unit circle triangle. Well, side squared is x squared, plus my other side squared would be y squared, equals 1 squared. Well, 1 squared is just 1. So it's just x squared plus y squared equals 1 every single time. Well, the cool thing is x stands for my cosine. And y is the exact same value as my sine value. So all the fundamental identity of trigonometry does is it replaces your sides with sine and cosine. So our fundamental identity of trigonometry is going to be cosine squared alpha. Now we don't use theta because it's an identity. If you use theta, it's not going to be the end of the world or anything. It's just usually when we're talking about identities, we use alpha. Plus sine squared alpha equals 1. Now it's weird that they put the squared here. Even though the squared is kind of in the middle of it, it's still saying find your cosine value and square it. All right, so this cosine squared alpha is the same thing as cosine alpha squared. So if cosine alpha is 1/2, cosine squared alpha is 1/2 times 1/2. All right, so don't let that being there confuse you. It's just squaring like any other. All right, that's the fundamental identity of trigonometry. We will use that quite a bit. All right, not as much in this chapter. We're going to do some practice with it, but when we get to identity chapters, that's going to be like the heart and soul of a lot of our problems, because we can get to a lot of stuff just by knowing this. All right, that's where we're covering it now. Yes?
If the alpha's squaring, then why is there still a square? Or is that just...
Say that? I'm sorry.
If the alpha, you said the alpha is supposed to be squaring it.
Oh, the square actually squares it.
Okay.
The alpha is just a number. So this might say cosine squared of pi over 3.
Okay.
You're just going to find the cosine of pi over 3 and then square it. And you'll see it in the next example what I'm talking about. All right, our first example is find cosine alpha, given that sine alpha equals 3/5 and alpha is in quadrant 2. All that information is important. What I start with every single time is I start with the fact that they told me quadrant 2. Because on the surface it doesn't look super important, but it is. Because knowing what quadrant is it in tells me whether it's going to be positive or negative. So quadrant 2 is all, I'm doing it backwards for you guys, all students. So it must mean that sine is positive. So what I'm going to do on these problems, underline it, something like that. I'm just going to tell myself that sine is positive and cosine is negative. Well, our sine's already positive because they gave me the sign. They better have got it right. But we're looking for cosine, so I know my answer needs to be negative. So if it comes up positive, I'm just going to change it to negative. All right, so let's write down the fundamental theorem of trigonometry. So we have cosine alpha plus sine squared alpha equals 1. Well, sine of alpha equals 3/5. So we are going to replace our sine alpha with 3/5. That square is going to stay there. The only thing that's going to disappear is the sine alpha, because that's what I'm replacing. So we are now going to have cosine squared alpha plus sine alpha should no longer be in there. We should just have 3/5 squared. And that's going to equal 1. From here on out, it's just regular algebra. It is just solving for cosine squared alpha. But it's almost like just, if I put x squared there, same solving. So the first thing I'm going to do is I'm going to square the 3/5. You can do this in whatever order you want to. If you're really good at solving these, you can jump ahead. But I'm just going to stick with, well, that's going to be 9 over 25, which equals 1. I'm going to subtract 9 over 25 from both sides. What I do, when I run out of room in these little boxes, you'll see me just put an arrow saying I moved it up here. All right, that's all those little arrows mean, is continue on. All right, so we're going to have cosine squared alpha is going to equal, I'm going to change the 1 to 25 over 25 so we have a common denominator. So we'll have 25 over 25 minus 9 over 25. So cosine squared alpha is just going to equal 25 minus 9 is going to be 16 over 25.
You don't want to simplify.
I do want to simplify. I just want to stop here for a second. What would I do if this was x squared? What would I do to both sides to get rid of the square root? Yeah.
You would find the square root of 16 over 25.
Yeah, I would just take the square root of both sides. We're gonna do, trig works just like everything else. If you need to get rid of a square, you're going to take the square root of both sides. So I'm going to take the square root of both sides, which gives me that cosine alpha equals plus or minus the square root of 16 is 4. Square root of 25 is 5. We can't have two answers because cosine cannot be both positive and negative in one quadrant. But we already said it needs to be negative. So based upon the fact that we said it needs to be negative, and the fact that it could be either positive or negative 4/5, that's going to lead us to the answer that its cosine alpha is going to equal negative 4/5. And that's our answer. Boom, 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 boom. I'm going to double check what time we're out of here. Okay, we got time. All right, I'm going to skip the next one just for right now, and we'll go back to it. I want to go to just the bonus. I put these problems on the homework because we can't overthink sine and cosine. We can't overthink things and just let it blow our minds that they're sine and cosines and I can't do the same stuff I always did. So we have problems on the homework that's going to look like this. It's going to say the sine of 4 theta. You need to find the sine of 4 theta if theta equals pi over 8. Now it looks a little confusing, but boil down to the fact that you can do everything in here algebraically before you even look at the sign. So if I just gave you find 4 times theta, all you would do is take 4 times this. And that's all we're going to do here. We're just going to do 4 times this and then find the sine of whatever that results. So more mathematically looking, we're going to go sine of, I'm going to go ahead and say 4 theta. That's going to equal sine times 4. And since theta equals pi over 8, we're just going to put pi over 8 in theta's place. That's going to equal sine of, and you could jump here to the actual answer, but I'm going to go through each step, 4 pi over 8, which is going to equal the sine of pi over 2, which we already said before is that one that's straight up, so that's 0, 1, so it equals 1. Don't overthink sine and cosine. If you can do stuff in here to simplify it, do that first, and then go from there. All right, questions on that? No? What did I say, 25? Let's go ahead. I'm just going to stop there. I'm going to go ahead and stop there. Actually, scratch. I'm just going to rush through the next one just so you have another example. So I'm going to talk it through you really, really quick because I do have 2 minutes. We're just going to kind of rush through it. So I know what cosine is. Our cosine theta, alpha equals 12 over 13. So I'm going to say 12 over 13 squared plus sine squared alpha is going to equal 1. Well, now it's just algebra. It's 144 over 169 plus sine squared alpha equals 1, which is going to be sine squared alpha equals, I'm going to change the 1 to 169 over 169 minus 144 over 169. So we're just going to have, let's carry that up here, sine squared alpha equals 25 over 169. Then we're just going to take the square root of both sides because we can do whatever we can. If it's x squared or sine squared, it doesn't matter. We take the square root of both sides, and I come up with sine of alpha equals plus or minus 5 over 13. Why did I do that whole problem and Mr. Payne will still take a point off? Why am I still going to take a point off, Maya?
Because you didn't choose the positive or negative.
I didn't figure out if it's positive or negative. There only could be one per the given quadrant. I am in quadrant 4. That's why I usually start off with doing it first, but this time I neglected to do that. So we're in quadrant 4. All students take calculus. In quadrant 4, calculus is positive. Cosine is positive, and sine is negative. So that means we're going to take the negative. So based on that 2 bits of information, we are going to have sine of alpha equals negative 5/13. All right, this homework